So it looks like the room is the perfect size right now. I think we've got almost every seat full, which is exactly the kind of fullness you want in an active learning class. So, so it's my pleasure to introduce Eric Mazur. He did his physics education up through his PhD at the University of Leiden in the Netherlands. And he's currently professor of physics and applied physics and dean of applied physics at Harvard University. He's also a member of the Faculty of Education at the Harvard Graduate School of Education. And he's currently president of the Optical Society. And because of that, are you actually on sabbatical? Yeah.
I'm on sabbatical, and I'm here for the big meeting of the Optical Society.
Right. OK. And so because of his sabbatical, we've been enjoying his presence on the West Coast a lot more than usual. So that's been great. Eric is known for both his contributions in nanophotonics, so he has a very active large laboratory, and as an internationally recognized educational innovator. In education, he's widely known for his work on peer instruction. And he wrote this book in 1997, and it was the first thing that I read when I got started on active learning. And it's very readable, kind of a third or so you can read, get the hang of it, and then lots of examples, where once you go through the examples, it's kind of like, I get it. So I think that's really inspired and educated a lot of people on this. And in general, peer instruction, active learning, methods for engaging students in the classroom and beyond. He has received many awards for his work in both physics and in education, including the Millikan Medal from the American Association of Physics Teachers in 2008. And he has founded several successful companies, including producing instructional technologies, and he holds numerous patents. So, and he's an inspirational speaker, and so it's my pleasure to have him introduce him here today at Stanford. Thanks, Eric, for coming.
I think I'm going to stand in front of this thing. Sort of, it's a wall between you and me. Anyway, a number of years ago, I was boarding a flight to Latin America. And as I sat down in my seat, I found myself next to a young woman who told me she had just graduated from the university in Chicago. And we started talking, and she told me she was currently working for a cloud-based education company. And I just founded my own cloud-based education company, so I thought I better find out what she does. Turns out her company made flashcards, these cards that have questions on one side and answers on the other, for smartphones. Now, those of you who have followed my career know that I don't place much value on memorization, so I almost rolled my eyes. I managed to remain polite, however. And earlier that same week, I had attended a talk by Rudi Rödinger, who is a psychologist from Washington University, who actually studies memory, and a lot of his work is done by studying how much students retain from studying with flashcards. And right around that time, he had published an article which got a lot of attention in the national media. It was published in Science magazine, that showed that if you have students study with flashcards, they remember quite well for a short amount of time, like 3 days, right? If you study them over the course of the next 3 days, you're sort of at 85%. But if you have students study with flashcards, and then you wait 1 week and you test them, you find that they remember only 35%. In fact, if you wait another week, you can barely measure it. I thought she should know that, given that she was working with programming flashcards on smartphones. So I grabbed my iPad out of my briefcase, and I pulled up the article that had this graph, 85% after 3 days, 35 after 1 week, almost nothing after 2 weeks. And I handed her my iPad. And she looked at my iPad for no more than 10 seconds. And then she handed me back my iPad, and she looked me right in the eyes, and she said, "But we only guarantee that they will pass the test." You know, that's exactly. Yes. Yeah. I had never thought about it that way. And it brought back all kinds of memory. You see, my oldest daughter was actually an undergraduate at Harvard. Great, right? And during the weekend, she could come home. On Monday morning, we'd drive back to campus. And at that moment, I vividly remembered a Monday morning that we're driving back. I was in the driver's seat. She was sitting next to me in the passenger seat. And as you might imagine, you know, given my interest in education, I was often talking to my daughter about, you know, studying habits and how to study and so on. But anyway, we're driving, and I look over my shoulder, and there she is using flashcards. Now, that was something that had never come up in my vocabulary. So I said, Natalie, what are you doing with flashcards? And she looks at me and she says, well, I have to, you know all these amino acids. I said, I have an app for that. Seriously, you know, some of my work is in biophotonics, and occasionally I do need to refer to amino acids, but unfortunately I don't use them often enough for them to stick. So I rely on the app to refresh my memory. And she looks at me and she says, Dad, we're not allowed to use the iPhone during an exam. So that made me realize that even when a student has the best of intentions, their study habits are dictated by the way we test them. And, you know, I've gone around the country for, well, what was it? When did that book appear? 1996. So over 20 years, bashing the lecture as an outmoded approach to teaching that focuses on the transfer of information, never really realizing that on the output end of teaching, you know, we use methods that also are focused on the regurgitation of information or the application of rote, memorized procedures. And consequently, instead of developing 21st century skills, our assessment is really mostly focused on ranking and classifying students. You're better than she is, she's better than he is, and so on. And I'm going to argue that our ability to actually predict how people will do in the workplace are, you know, extremely limited and probably even very misguided. So this is what I'd like to do in the next 45 minutes or so. One is I'd like us to think collectively a little bit about the purpose of assessment. Why is it that in an institution like yours or mine or any other, we're doing assessment? What is the goal of assessment? Secondly, I'd like to discuss a few problems that I have identified with assessment. I already alluded to one big one, namely that it forces our students to engage in study habits that are not conducive to learning. But I'll quote more. And because I'm an optimist, I don't want to end the talk with, you know, on a negative note. So I'll end with 4 suggestions of potential improvements of our assessment practices. So here's how we're going to start. Let's break up for a moment into little groups of about 4. So take a few people around you and form a little group, appoint one note taker, and write down as many purposes of assessment as you can think of. I'm going to give you about 2 or 3 minutes for that. So make a list. This is why we're assessing. Go ahead. Do you know Alex?
What?
Do you know Alex?
No, I don't.
I knew Alex.
I was related.
He was an undergraduate. He was a student of mine in his senior year, right?
Or was it also once senior year, once junior year?
former student of mine.
Exactly.
He was
At Harvard?
Hi, Roberta. Okay. How many of you have more than 5 items on your list? Oh, good. You've been working hard. Okay, so there was not enough time for everybody, but hopefully collectively we've come up with a complete list. So I want you to tell me some of the things you've written on your list. Don't rattle off the entire list. If you get to speak, take the top item and then let somebody else say what he or she wants. Who wants to kick off?
And I'll start with one that I'm not sure I can get too many people. Learning. I learned from having to take bar exams. I learned more law taking bar exams than I learned in school. So there's a lot of learning from cramming. There's a lot of learning from organizing your notes. There's just a lot of learning, and I think that's left out. The other ones maybe a little.
Okay, so wait, we'll switch to somebody else. Are there any students here in the audience? Would you have come up with that idea, learning?
Perhaps,
I happen to personally completely agree with this. The assessment should be a learning opportunity. I think, however, usually, unfortunately, it isn't. Okay, learning. I should not get into any details here. Who else? Next one.
Evaluation, whether the student is ready to go to the next level.
Okay, so sort of, benchmarking. See if you're ready for the next level. Who else?
It could be feedback to the instructor, like revealing a mismatch between what they thought the students were learning and what they actually didn't learn.
Feedback to the instructor. Next one. Yes.
It incentivizes students to study.
It incentivizes the student to study. In other words, if we wouldn't have assessment, then there would be no incentive to learn anything. Have you ever observed small children? They learn without any test, right? So we already see that there's some kind of disconnect there between, young learners learn and I would say adult learners too, because once you leave college or grade school or whatever, there are no assessments. You have to assess yourself, and you have to continue to learn in order to. But I agree, that's one of the reasons that many people see as essential to having the assessment the way we have it now. Yes?
It can be a form of gatekeeping. Who gets access to certain institutions or coursework?
Gatekeeping? Anything that's not been read off any of the lists in the back? Yes, Tatiana?
I think the purpose of the assessment is to measure something for whatever. It's about to measure something, whatever you're going to do.
Collect data. Yes?
It can be about assessing the educational system, like in standardized tests or concept
To
inventory.
assess the quality of education, right? Yes?
Depending on the style of the assessment, it could also be an engagement strategy. So if we're thinking about project-based learning and there's a final maybe community-based presentation.
Very good. It could be an engagement of the students in case of an assessment like project-based learning. I think you had your hand up.
Relative to each other?
Ranking the students relative to each other.
Highlighting what is measurable over what is harder to measure.
Highlighting what is measurable and what is harder to measure. Yes, one more.
I don't know if this has been said before, but, and I may be revealing that I'm not a good test writer, but when I write tests, I always like to try to write questions that allow the students to extrapolate the skills they've learned in my class to new areas. So they learn about new areas.
Very good. So in order to see if the students can transfer, you use the word extrapolate, I'll use the word transfer here, skills that they've learned in the class to a different context. I think that's probably a measure of real learning. So I think that's not bad test writing. I think it's really good. Your students might not like it, but you know, some of the other things I've heard is because we've always done it. Or, you know, so that we instructors can travel to a conference and keep our students busy back home. But this is the list that I had written down, and I think we've heard all of that, right? To rank and rate the students on some sort of a scale, to rate the professor and the course, to motivate the students to keep up with the work, otherwise they wouldn't study, to provide. I'm saying that not because I believe in it, I'm saying that because that's what, you know, sort of is considered as being true often. To provide feedback to the instructor, which Professor Burkett mentioned, but also to provide feedback on the learning to the students so they know what they've learned in the course. To provide some kind of, we heard that in two different ways, some kind of instructional accountability and also to improve the teaching and learning. So I think there's a pretty good match between what you came up with and the list I had made beforehand. Now look at this list. I mean, it's a lot of things, it's a lot of things to accomplish with one type of activity in a class. In fact, I would argue some of these goals are probably in complete conflict with each other. So right off the bat, we see here that we have, you know, we have an educational practice that has a very diffuse goal, and a goal that cannot be completely satisfied if you take all of these goals together. Okay, so I already mentioned, shifting to the problems that I've identified, that, you know, a lot of testing is inauthentic in the sense that it doesn't really test what students are able to do and skills, but it tests sort of short-term memorization, which the work of Ruddy Rödinger shows, you know, is only good for a few days. And, you know, I would actually go a little bit further now and say that not only do many tests simply test memorization, but even those that claim to study problem solving do not do so. They test what I would call inauthentic problem solving. Let me explain. What is a problem? When you have a problem in life or in your work or whatever, typically you know what the desired outcome is. The key point is not to come up with a desired outcome. The key point is to come up with a solution that brings you to the desired outcome, right? I mean, let's say you have an interview tomorrow in Boston, and you head to San Francisco airport to take the red-eye flight, which is probably not a good idea for an interview, but let's say you do that, and you get there, and United tells you, sorry, our flight is canceled. You have what is called a problem. The outcome is known. You want to be on the East Coast in time for that interview. The question is, how do you get there? I think that most major problems in science and technology in life fit that pattern. You're, you know, at the head of a hedge fund. Outcome is known, you know, you need to have more money. The question is, how do you get there? You are a doctor in an emergency room. Patient is brought in on a stretcher, obviously in bad shape. You know what your goal is, to get that patient back out of the emergency alive. And you have to find out how to accomplish that goal. Now, and I would say, especially in the sciences, we're guilty of this. Most of the problems with which we assess our students fit a very different pattern. We give the students a problem with the expectation that they will apply a known procedure to find an unknown answer. And the evaluation is on the answer. That's what is going to determine whether it's right or wrong. Let me take an example, sort of an imaginary example from my own field. A car is going along a road, and blah, 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 and so forth. At some point, it hits the tree, and after it says, what was the velocity of the car just before it hits the tree? So that last sentence tells the students, I have to calculate a velocity. Student will think, what are the formulas that I have memorized to calculate velocities? Well, there's this one, there's that one, there's that one. The first one, I can't use it because I don't have all the variables. Second one, oh wow, exactly all the missing pieces are given in the problem. Student puts in the numbers, turns the crank, out comes the answer, 4.2 meters per second. And the student is evaluated on that number. Now, in order to show, sort of to illustrate how, this can yield to a completely incorrect interpretation of students' ability, let me sort of, for those of you who are not familiar with it, show some of the work from Benjamin Bloom, who was an educational psychologist in the 50s in the US. And he came up with sort of a taxonomy of thinking skills, sort of loosely ordered from lower order thinking skills at the bottom to higher order thinking skills at the top. At the bottom is remembering facts, like, what year did a certain event happen, or an equation, or any other fact. The next one is understanding the connection between different facts. The third one is taking what you've learned and apply it to a different context, which is why I'm really grateful that you brought that up so early. The next one is analyzing, determining what knowledge you need in order to solve a given problems. In most of university education, the context tells you that. You go to a physics exam, so you have to use physics knowledge and so on. So there's very little opportunity actually to get to that level. The next one is evaluating, determining whether whatever solution you come up with is plausible and meaningful and reasonable. And then all the way at the top, there's that elusive creativity, innovation that we all aspire to, creating new knowledge, creating something that is new. I would argue that in most institutions, including mine, we don't even get to level 3, applying. Just inspired in part by what you just said. I think it was about 2 or 3 years ago, I was giving a talk in a pretty good university. I won't name any names. Let's just say in Connecticut. And I gave a talk about the approach to teaching. And after my talk, one of the professors from the physics department came to me and said, "I had something really strange happen in my course this year." He had been teaching physics to engineering majors, and he wanted to make that physics relevant to the engineering major, so he put it into a real-world context. And the context he used was baseball. I mean, there's a lot of physics in baseball, right? Trajectories of balls, collisions between balls and bats, runners running. So in class, he would use examples from baseball. On the homework, he would put baseball problems. On the midterm examination, baseball problems. At the end of the semester, he was preparing the final exam, and he realized he had run out of baseball problems. So he put some football problems on the exam. Professor complained to students, "We have never done any football problems before." You're laughing. I think we should really be crying, because you have to admit, if you can't transfer your knowledge from the context in which you've learned that knowledge to a new context, you have not really learned. Let me actually give you an example. Some of you may know about Fermi. Enrico Fermi was an Italian physicist who, Nobel Prize winner, who then later in his life joined the faculty in Chicago, and he was known to start his classes what are called Fermi problems. He would just, come in, and the first thing he would ask is, how many piano tuners are there in Chicago? You could guess, but you won't have much confidence in the guess. Or you can think it through. How many people are there in Chicago? So it might mean how many families, and so on. You can sort of argue your way through it and get a reasonable answer to this question in which you have a lot more confidence than a wild guess. Now, I'm not Enrico Fermi, but these questions sometimes pop up in my head. So let's take one of these questions and then slowly deconstruct it until it becomes a standard textbook problem. Let me first give you what gave rise to that problem. I was painting my dining room many, many years ago. And on a Saturday morning, I ran out of paint. I had to go and buy a new gallon of paint. So I hopped into my car and went to Harvard Square. For those of you who are familiar with Harvard Square, there's a hotel, which keeps changing its name. I think it's called Harvard Square Hotel now. But it sits on stilts. It's elevated from road level. And on that first level are two parts, each having roughly 20 parking spaces. And since that's central in Harvard Square, it's the best place to park when you go shop. It's bounded by two streets, Mount Auburn Street and another street whose name I don't know. And typically when I would go there, I would go Mount Auburn Street, go into the right half of that parking garage. And of course, there's never any spot free because it's a very popular street. Go out to the other street, turn in the other half, go back to Mount Auburn Street, go around and around and around like that, going into traffic, out of traffic, until you finally see somebody who walks, with keys in their hand to a car, and then you say, yes, and then you quickly, but then you see that the person goes to the other half of the garage from which you are. You quickly go into the street, but there's another car that grabs the spot in front of you, Murphy's Law. So that Saturday morning, I said, you know what, I'm gonna turn off my engine, I'm gonna stay on the right half, give up on the 20 spots on the left half, and strange physicist that I am, as I turned off the engine, I thought, how many minutes is this going to take? After, thinking about it for about 15, 20 seconds, I came up with the answer, 3 minutes. So I looked at my watch. You know what? 3 minutes later, somebody showed up and freed up a spot where I felt so good. Now, let's imagine we turn that into a problem, right? On Saturday afternoon, you turn it into a parking lot with unmetered spaces near a shopping area. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before someone frees up a space? I promise you, if you were to put this on your exam, your students are going to go to the dean to try to get you fired. What are some of the skills you need in order to answer that problem? Well, you need to make assumptions. You need to develop a model, a way of thinking about this problem. And then you need to apply that model. In terms of Bloom's taxonomy, we are all the way at the top of that pyramid. Now, we don't want to get fired while giving exams or after giving exams. So, let's sort of try to, take away the main pain points for the students and slowly turn this into, as I said, a standard textbook problem. Of the skills that are listed on the bottom left, which is the one that students hate the most? Making assumptions. I heard several of you mention it. Yeah, scary, right? What if you make the wrong assumptions? It never occurs to students that you could always revisit your assumptions. But also, let's think about it. Assumptions is perhaps one of the most important skills to learn. What distinguishes one doctor from another doctor, one politician from another one hedge funds manager from another, one CEO of a company from another? It's not the ability to, plug numbers into equations and get an answer. It's the ability to make informed assumptions and know how to revisit assumptions. I know that if on my exams I don't specify whether you can neglect gravity or friction or whatever, even if it's completely clear from the context of the problem, the first thing that happens is students go up, Professor, are we supposed to assume here that? They want you to take the responsibility for the assumption rather than taking it themselves. Well, again, since it's such a loaded point, let's remove the assumption. Even though I think that by removing assumption taking from our education, we rob the students of a very important practice. So out goes the assumption. We add one sentence. On average, people shop for about 2 hours. 2 days is obviously too long, 2 minutes too short, so 2 hours is sort of right in the ballpark. In terms of Bloom's taxonomy, maybe we've gone down a notch, but we're still pretty close to the top. Well, I think students would still be, really upset, and they've never seen any problem. They don't know what the model is, so this would still probably give us a lot of trouble if you put that on our assessment. So let's now take out the model too. We implicitly put the model into the problem. We add another sentence that says, assuming people leave at regularly spaced intervals. Now we've dropped down significantly because we're essentially all the way down somewhere around the applying level. I think, and in a sense, now we've given everything to the student that is necessary to answer this question. You just have to put it together. I think students would still revolt. Professor, we've never done any parking lot problems before. So let's now turn it into a standard back of the chapter or end of chapter textbook problem. On a Saturday afternoon, you pull into a parking lot with unmetered spaces near a shopping area where people are known to shop on average for 2 hours. You circle around, but there are no empty spots. You decide to wait at one end of the lot where you can see and command about 20 spaces. How long do you have to wait before someone frees up a space? And I can see some of you stare at that screen and probably think, that, isn't that what we started with? Yes, but somewhere in the course of instruction or in the textbooks, the students have seen this equation, colloquially known as the parking lot equation. The time you wait is the average time that people shop divided by the number of spaces. And all they have to do is plug in the numbers. And by that, we've all of a sudden dropped down to absolutely the lowest level of Bloom's taxonomy. Now, maybe I exaggerate a little bit, but I challenge you to take a cold, hard look at examinations in your own class or that of your colleagues, and I'm sure that you'll find that a much larger fraction than you would want falls into this last category rather than into the first category. And I think this is particularly important in the 21st century because we all carry on our belts or in our pockets or in our purses the devices that can solve this, that can do this, that can put numbers into equation and get them out. So, I predict in a sense that jobs, just as assembly line jobs have been eliminated by robots, so will any job that is related to remembering information, just remembering it, or plugging numbers into equation be eliminated by computers. So I think therefore right now, especially right now at the beginning of the 21st century, it's really important that we focus on real problem solving. However, there's a problem with real problem solving, and that is that the solution is erratic. The road to creativity, the road to innovation is littered with failures. You try something, doesn't work. You try it a different way, doesn't work. You try it a third way, if you're lucky, it works. Think about it. Thomas Edison, who invented the light bulb, they're going away because they're replaced with LEDs and fluorescent, but that was a major invention. It increased the productivity around the globe. It was what the NSF would call a transformative discovery. He didn't just invent the light bulb. I think there were something like 300 failed prototypes. Most people would have gone to him and said, Thomas, you're wasting your time. It's never going to work. But he saw each failed attempt, not as a failure, but as a step towards success. Unfortunately, our educational system, our approach to teaching, and in fact I would say society as a whole, stigmatizes failure. It's bad. Well, if you want to be creative, you're not going to, take a one-step jump from problem to outcome. And in a certain sense, the way we assess our students, makes them afraid of failure. You make a mistake, you lose a point. Better not make a mistake. So in a sense, our grading practices are incompatible with real problem solving. I'm going to make a little jump here. I'm going to show you a picture, and this picture needs no words. You can see right away what this is. And if this picture elicits pleasant memories, then I'd like to talk to you after my talk. What are some of the feelings that come to mind when you see this picture? Sympathy. What else?
Anxiety.
Anxiety. Just blurt it out. No need to raise your hand. Stress. All these words are so conducive to learning, are they not? Stress, anxiety. But there's something else about this picture which is really peculiar. I mean, not this picture in particular. It happens to be an exam taken in Norway, but it could be anywhere in the Western Hemisphere. But there's something else that is really peculiar about this arrangement. What is it? No one is talking to anyone else. Complete isolation. Every student cut off from any source of information and any other human being. Because that's how we're going to work later, after we get our degrees. I was recently reading the New York Times, and I saw an article that now when you take the SAT exam, you're not even allowed to bring in a watch anymore. No. Soon you'll have to start taking that exam naked. In fact, I said that when I gave this talk a few months ago in Chicago, and somebody sent me a picture of cadets in India taking their exam in a big field in their underwear because of massive cheating that had occurred. So what I'm just saying here is pretty close to the truth. But I mean, think about it. Think about it. Why are we robbing people of an opportunity to look up any information or to talk to each other when society works very differently? When I write a paper about nanophotonics, there's not somebody standing next to me saying, Eric, you're not allowed to look up that paper by your colleague at Yale. You should have known this all by heart. I can look up whatever I want, whenever I want it. And I can consult whoever I want, whenever I want it. It's not about memorizing the information. It's knowing about how to use the information. Then why, why are we examining students under circumstances that have nothing to do with the way they're going to work later? How can we imagine that what we measure, somebody mentioned measuring, which is very good, because in a certain sense, assessment is a measurement. But how can we imagine that what we measure under those circumstances is any reflection of a person's ability to do well later in the workplace? Traditionally, the assessment has been sort of a high-stakes affair, culminating in the final exam. And, in my institution, for example, we have a reading period where students are meant to study for the exam. It used to be 2 weeks. It's now much less. I think they're taking the advice of Rödinger into account that, it's only 3 days, so that you can remember, so it's better to make it shorter. Seriously, I'm not joking. But as we all know, high-stakes examination promote cramming, and cramming means the information is stored only in short-term memory, which means there is neither retention nor any transfer. Then there's another thing that I really only stumbled on much more recently, and that is that assessment produces a conflict among, the faculty here in this room. You may agree with what I'm going to say. A couple of years ago, I switched from teaching in a space like this to project-based learning. So students are sitting in groups of 5 around tables, they're working on a project, and rather than being the teacher, I'm sort of the coach. I'm helping them, do the best project that they could possibly do. And then at the end of the month, we have a project fair, and the first year that I did that course, I became one of the judges who had to judge the projects. And I realized, that it was very uncomfortable for me because I'd been the coach during the entire month, and now all of a sudden I made this Jekyll and Hyde transition and became the judge. Think about it. Would combining the roles of coach and judge be accepted anywhere else in society? I don't think so. It will be considered, unethical. The more I actually think about it, the more I think that education is one big cartel. We wear these robes at the end of the year to remind ourselves of that fact, right? So, how do we resolve that conflict? Because it is a conflict, right? We resolve that conflict by hiding between a thin veil of objectivity. I am going to judge you being the students, in a way that's completely reproducible and fair and objective. It involves no feelings. But think about Bloom's taxonomy again, which is the only thinking skill on that list there that we can truly assess completely objectively. Unfortunately, that's all the way at the bottom. So in a sense, that conflict forces us down Bloom's taxonomy. I'm going to, let's take that question about, for example, that I mentioned at the beginning, car along the road hitting a tree, right? If the right answer is 4.2 meters per second, if a student writes down 4.2 without units, that's wrong. If a student writes down 8.6 meters per second, that's wrong. If a student writes down minus 4.2 meters per second, it's wrong. If it's 4.2 meters per second, it's right. I can make all those statements without, any interpretation or totally fair. But do I know whether or not the student has actually learned something? No, unfortunately not. And then there's so much other stuff that has bothered me over the years. Grade inflation, cheating. Why would a learner with a real intention to learn be cheating? Have you ever seen a 4-year-old cheat when learning to tie his or her shoelaces, or a toddler trying to put a fork in his or her mouth? No, of course not. Cheating is not a problem with the students. Cheating is a problem with the assessment. Okay, so I have about 15 minutes left, so let's talk quickly about some improvements. The first one is, let's mimic real life. Why cut students off from information if they'll have access to information? In fact, if we cut them off from information, that's already a giveaway that what we want to test is memorization of information. But memorization is useless because think about yourself, what you know right now. I think it was Einstein who once said, education is what is left after all that is learned is forgotten. Nanophotonics, take my own field. I never learned that in high school or in college or in graduate school. There was no nanophotonics. I had to learn this on the job. In fact, probably that's true for most of you. What you use now as information, you learned fairly recently. And things should stick in memory, not because somebody tells you, Eric, you can't be a physicist unless you know this. No, it should stick because you use it. So, I knew this fairly early on. And the first year that I taught, I gave my pre-medical students, because initially I started teaching the pre-meds, I gave them a sheet of formulas. I thought, why would a doctor need to remember the parallel axis theorem, right? So I basically gave them a series of formulas on a sheet that first year. And the second year, some students came to me and said, couldn't I make my own sheet rather than, using the sheet that you prepared? And I thought about it. I said, okay, one index card, 5 by 7 inches, only to discover that the students develop a microscopic handwriting where they put the entire book on one side of an index card. So the next year I said, just bring the book. But then the following year, some students came to me and they said, you know, in high school I used this other book, not the book that you have assigned for this course, and I actually liked that other book very much. Could I bring that book to my exam? I realized that if I let that one student bring his or her book to the exam, I had to allow any book, right? Because not everybody has the same book in high school. So I said, sure, you can bring any book you want. Some students, you know, walk into class with 5 textbooks. And the following year, believe it or not, some students came to me and they said, can I bring the solutions to the homework and my notes? I thought about it, and then I said, you know what? You can bring anything to the exam except another living person. But then, more recently, I've started to assess students on their laptops. So now they have access to Google. Is that a problem? I thought about it for a moment, and then I thought, actually, think about Bloom's taxonomy again. What does access to Google do? What access to Google does is that it basically eliminates that bottom row from Bloom's taxonomy, right? Because I mean, why would I ask something that you can Google that you can Google online? Well, in a sense, I would argue any question to which the answer can be Googled is not an authentic assessment question. I mean, there's a price to pay for this, which is that I have to Google my own questions to see if they can be Googled. But that's doable. I think so. In a sense, by giving access student to information, you push them higher up on Bloom's taxonomy. Oh, I was a little bit too fast here. I'm going to have you watch that clip. It's about 1 minute long. I want you to pay close attention because there are going to be 2 questions. I'm going to give you a test. The first one is, this is a class at Bandung Institute of Technology, which is sort of Indonesia's form. I chose that because I think there's not many people who speak Malay here, or Bahasa Indonesia. But anyway, this class is at that institution. I want you to A, determine what discipline it is, and B, what are the students doing? All right, so maybe that first question is not very fair, right? Because you couldn't hear what they were saying. So let me tell you, the subject is statistics. Have you ever seen students having fun with statistics? Now you have. Now the harder question, what is it exactly that the students are doing? What is happening in that classroom? Playing bingo. Playing bingo. Taking a test. Taking a test. Exactly. They are taking a test. Is that not a cognitive dissonance? Right? When you see people A, having fun, and B, talking to each other. The first time that I encountered this test method was at the University of Delaware when I was Phi Beta Kappa visiting scholar, which means you spend a few days, you visit a few classes. And on my schedule was this visit to a biochemistry class. So at the appointed hour, I went to the classroom in the chemistry building. And as I got to the door, I saw that the classroom was still empty. There were 5 round tables. And the professor was putting down pieces of paper on the table. So I walked over to him and I introduced myself. And he said, "Oh, it's great you're visiting today. We're having an exam." I thought, okay, good, so I'll go outside and I'll do some email. I hadn't been able to catch up on my email, so this was perfect. So I said, should I wait outside and then we talk later? No. I want you to take this test. I said, what is this test about? He said, hemoglobin. I said, I don't know anything about hemoglobin. I was not very happy at that moment. But before I could protest, I found myself at a table with 7 other students, and I just had to sit there. I was in a bad mood. Anyway, at some point he said, you can turn around the exam. I turned around the exam. It was a multiple choice exam. My mood went from bad to worse, because I'm not a big believer in multiple choice tests. Anyway, so I just sat there. I knew no answer to any of these questions. And I noticed that the students had a little strip of paper on which they wrote down for themselves the answers to each question. 1, C, 2, B, and so on. After about 20 minutes, the instructor got all these little strips of paper, collected them. That was 50% of the grade. He told me later. And then he put on the table one card called an if-at scratch card. There's an example of it. So on the vertical, you can see the numbers of the question. They went on to 20 or something like that. And then A, B, C, D for the 4 choices. At the intersection is this paint that you scratch off that's on a lottery card too. 1 card per table. So the instructor said to the students at my table said to each other, who is going to be the scratcher? Do you want to be the scratcher? So they appointed a scratcher. The scratcher said, well, 1 was an easy question. I got C. What did you have? C, C, C. Should I scratch off C? And then the other students, they looked at me. I said, I don't know anything. So they scratched off C. And as they scratched off C, they revealed this star. And they went, yes, we got it right. I thought, okay, so now we're playing bingo. So I thought, what is this stupid exercise that I have to sit through? But then they went through the second question, and the second question, something really interesting happened. Half the students had answered A. The other half had answered B. The A's did not want the B to be scratched off because they wanted A to be correct. The B's didn't want A to be scratched off because they wanted the A to be correct. So the students went, don't you remember in class when the professor said that when hemoglobin, blah, 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 and so on. All of a sudden, they were talking like biochemists. It was no longer about the answer. It was how you got to the answer. Then, finally they settled on B. They scratched B. There was no star. Bummer. But here's the genius of the method. If you don't get it right the first time, as they did for C, you can try the second time for half credit. Notice that they got 4 points here. You score yourself. You don't need to ask the instructor. You can just put the 4. And if you need to scratch off 2, you put 2. And if you still get it wrong and you need a third test, you get 1 out of 4. And you still get it wrong, you get 0 point, but you know what the right answer is. Students actually went, aha, oh, yes, now I get it. This really turned the test taking into a learning opportunity. In a sense, the students were teaching each other during the test. By the time the test had been completed, they could add the team score, 23. They could calculate what their individual score was, 50% the individual, 50% the team score. One important caveat, if you do this, you have to make sure that there is no individual who scores much higher than about 60% on the individual part. Because as soon as an individual scores high, other students are going to rely on that individual. So you need to make sure that even the best student in the class is uncertain of his or her answer. It's a mistake that quite a few people unfortunately make when they implement it. It says, the team-based learning doesn't work. Well, team-based learning doesn't work when you use an individual curriculum for teams. So I'm going to skip this because I'm almost at the end of my time. I do that now on the computer, and there's a way of actually automating it so that you do not have to ask multiple choice questions. You can do this with automate. But Carl Wyman here on campus has also implemented it with 2-stage exam where the exam in the second round follows up on question in the individual round. The great thing about the way it's done this way is there is no grading. Do you realize that? By the time the test is over and the students walk out, they're happy, they've had the feedback, they've learned, and they're relaxed, there's no stress, no anxiety, and the teacher doesn't have to do any grading. Of course, you have to put a little bit more work beforehand in there, but it pays back handsomely. Second thing is, let's focus on feedback, not on ranking. I think ranking is a myth. I can make a long list of people who were extremely successful, dropped out of high school or college. And when I think back of all of the people who did really, really well with me in college or when I was there or in high school, I have no idea where they are right now. I think our ability to predict future success with grades is very misguided. Here's some data from my own classes. 2 metrics, 2 measurements, 2 different results. Here's the final grade. I was still teaching a fairly conventional class then. And here's the result of a test that tests students' conceptual understanding of the concept of force, which is the most basic concept in this physics class. You can see there's some correlation, but it's not that much. I think even a social scientist would say there's not that much correlation. But now look at this. Look at this. According to the person who designed this test, anybody scoring below 23 is still an Aristotelian thinker. Really has not understood the concept of force, is still connecting force with velocity rather than acceleration, and has not internalized Newton's third law. And you can see half the class is there, half the class, in spite of the fact that some got a final grade of over 90 and some failed the course. If you ask physicists to take this test, they score in the last 3 bins: graduate students, postdoc, faculty. Right? No error, 1 error, 2 errors. When I took the test, I made 1 mistake. I must have misread a question or something. I actually made a genuine mistake. But notice that there's still a big distribution here, right? I mean, the lowest one, scoring at the level of a postdoc, faculty, or graduate student, is 60 or a little over 60, and then 100%. Look at these 2 students. The one on the right understood the concept of force at the level of a professional physicist, but got a C in the course. The one on the left was still an Aristotelian thinker, but got an A. Is that objectivity, or is it an injustice? The next thing is, I think we should focus on skills, not content. I'm a big proponent, and I know there was Carl Wyman, you probably heard that here, of understanding by design, and in particular of backward design to curriculum development. Normally, when you teach a course, well, I hope, fortunately, that's changing right now, but typically in the past, when courses were designed, you started with course content. In this course, we will cover topic A, topic B, topic C, topic D. And then you start teaching, and then later you think about, how am I going to test that students have understood what I've taught them? A much better approach, which we follow in so many other practices in society, is to not think about the input end, but about output end. Because in this case, everything is determined by the content. So let's instead ask ourselves, what do we want to accomplish with this course? And ideally, you word that in terms of action verbs. After taking this course, you will be able to interpret medieval works of art in the context of, the history of Italy. Or you will be able to, use Newton's laws to solve this and that problem. This resonates with most faculty I speak with, but it's not that trivial a process. I mean, a lot of them, when they think about it for a while, and they say, well, they write in their syllabus, well, after taking this course, you will be able to understand topic A, topic B, topic C, topic D. That doesn't quite cut it, right? You have to think a little bit harder than that. Then you're going to ask yourself, what is the evidence I'm going to accept that I've actually reached those outcomes? And finally, how am I going to optimize the instructional approach in order to maximize the desired outcomes? That's such a logical approach. And there are 2 things. One is the course is then defined by the outcomes rather than the content. And you could even design a whole curriculum where the outcomes for different courses match each other. But more importantly, you've thought about the assessment right up front. And you're more likely to design an assessment that measures something that is actually meaningful. And last but not least, we should resolve this coach-judge conflict. We really must, you know, because that's the only way of getting higher up on Bloom's taxonomy. You know what I did? It was so simple in retrospect. I basically used external evaluators. I asked my colleagues to come and evaluate my students' projects. Let them be the bad guys. This way I can still be the good guy. And there's no emotional connection between them and my students. And I can be there to defend them if they need be. It has another huge benefit. It validates what I do in my classroom in the eyes of my colleagues. What's more, some students may have had some of these colleagues in other courses, because I ask engineering faculty, I even ask faculty from the music department to come and judge certain projects. And so it sort of, you know, validates for the students what I do in my course in their eyes. And lastly, I think we should also engage students in much more peer and self-assessment. I'm running out of time to say that there's one method that was developed at UCLA called calibrated peer review, a rather unfortunate acronym. Don't Google CPR. But it permits students to judge the work of their peers and their own work in the context of the work of their peers. Right? Normally, students hand in their exam, and then a week later it comes back graded by some authority. They have no idea how their work compares to that of others. Learning how to judge your own work is probably absolutely crucial in order to continue to learn later in life. So we miss an opportunity there to teach an extremely valuable skill to our students. I need to end. I want to end with a call to action. And the call to action is really very simple. We must rethink assessment, because if we don't rethink assessment, not only will we continue to educate the followers of yesterday rather than the leaders of tomorrow, I think if we do not rethink assessment, then our assessments will continue to fail to indicate who is going to be successful in their future careers and who will not. Thank you very much.
Constraints. So if you have to leave, go ahead. We won't be considered rude at all. If you have to leave, we'll take a few questions for about 5 minutes or so. Great.
Yes.
For a great talk. I was wondering, these ideas, if implemented, they would influence a lot of values, also how people are hired and evaluated overall, not just in school. Could you comment a little bit about what needs to happen for that and what the influences would be and struggles?
Well, I mean, you mentioned an important point, how people are hired, which is really important, right? So typically, I think most companies will not just ask for a transcript and base the decisions whether or not to hire on the transcript. They will interview people, which already, in a sense, is an indicator that they don't trust that transcript 100%, right? So I think that what we do right now, currently, with our grading, with numbers and rankings and so on, has very little influence on the hiring of people. Companies do whatever they think is best because they know that they can't rely 100% on what's in the transcript. So I think if we change it, it's not going to affect the hiring that much. On the other hand, I think if we change our approach to assessment, we might have a very profound, we hopefully have a very profound influence on the way students study and on the skills they learn.
So I think the biggest problem is the admissions officers at the universities, because they're relying on those test scores. And even though they say they aren't relying on the test scores, they are. And so students and teachers are targeting those assessments. And just like you say, they're all targeting memorization. So the question is, how do we get them to change what they're doing? Because the system will never change as long as the target remains the same.
Such a good point, right? I would have stated it slightly different. I would put the blame on ETS. You know, and I served for 5 years because I thought, you know, the big problem is how if the SATs would be meaningful, then the admissions reliance on the SAT would be would make sense. So rather than going to the admissions office, I said, let's try and change, in my naive thinking, let's try and change the SATs. So, this was back, I think, in the late 90s. I served for 5 years, so 3 years and then almost a full second year, 3-year team. And what happens is you get appointed to a committee of 3 university faculty and 3 high school teachers who meet 4 times a year to sort of lay the groundwork for the next SAT exam several years down the line. And essentially everybody brings problems and then you discuss one problem. And I thought, we need to have more conceptual word-based problems than rather just simply numerical and equation exams. And already I found that a number of the faculty were sort of uncomfortable with my question, but I said, I use them at Harvard. And so I managed to get a few of those questions on the slate of questions for AP exam. What happens then is that the statisticians of the ETS, they call them psychometricians, send these questions out to different universities. You may have had a letter from the ETS asking you to participate in a test of future questions of the AP. And then the next meeting, the psychometricians would come back and they report on the results of their testing. And they would look at me and they say, Professor Mazur, unfortunately, your questions are no good. And I say, why are they no good? He says, well, I say, I use them at Harvard. Well, our good students don't do well on them. So what they do is they take the new questions and they put in between them what they call correlators. These are questions that they've used for 35, 40 years, the same question over and over again, on which they've collected so many data that the standard error has been reduced to 0, so to speak. And if the new questions don't correlate with the old one, never mind that the old questions are simply plug and chuck questions that fall into that last category of questions, then they're bad. It's like taking a supertanker, which is already hard to maneuver, and removing the rudder. I think the real problem is grades. When I was developing this talk, I was invited at a professional development day at the Nueva School in Hillsborough, just north of here. Some of you may know that school. It's a really great school. And I remember that I did the same little thing. I asked the audience to talk about the reasons for assessment. And that day, the middle school students were ushering the people from one room to another. And in my talk, there were 3 middle school students sitting more or less on the front row because they had nothing to do during the talks. So when I asked people to tell me what they'd written down on the list, the first hands to go up were those 3 middle school students. I thought, I don't want to hear from the students, I want to hear from the faculty, so I just ignored them. And the more I ignored them, the higher up their hands went. And in the end, I gave in, and one student said, well, I like it when my professor asked me to reflect on what I've learned. And another said, I enjoyed when I get feedback. It was all about, first of all, looking at assessment in a positive way, but more importantly, it was all about what educational psychologists call metacognition, sort of evaluating one's own learning. My jaw dropped to the floor. I thought, I got to talk to these students, they have to apply to Harvard, But unfortunately, they left before the talk was over, before the discussion was finished, because they had to usher faculty again. So I went to one of the teachers and I said, those 3 students, it's amazing, And he got this smile on his face, says, we don't have grades. It's amazing what removing grades does to students, to a learner's attitude towards learning. But we're so much slaves of quantitative measurements, even if they're meaningless, and I think I've made a pretty strong argument for them being meaningless, that I'm afraid it's pretty hard to give that up. You had a question.
I wanted to share, there was an article that came out, I think, in Inside Higher Ed about a Mastery Transcript Consortium.
Mastery?
A transcript consortium of about 100 elite private schools that are kind of banding together to change the way that they teach. And so if we don't change at the college level, it might be forced from below. So right now it's mostly private schools, but they're at mastery.org, so I just learned about it.
Yeah, it was just the most recent edition of Inside Higher Ed. I saw it today. Okay, one more. And then we'll...
So just to revisit the notion of transfer, as Bruce talked about. So it seems like defining transfer is very tricky, because you basically need to define what a new context is, and just as an example, to an expert, everything's the same context. To a novice, everything's different. So it seems like talking about being able to transfer kind of begs the question about what students should in fact see as the same context.
Yeah, definitely. I mean, look, you could change the color of the car involved in a problem, and in a sense that changes the context, but still most students will recognize that as the same context. So, and of course there's a whole spectrum, right? I mean, from Newton's apple falling from a tree and the moon going around the earth, that's clearly a very, very different context, and we have to, applaud him for having recognized that it was the same principle applying to two very different contexts. So, and of course there's a whole spectrum between the two, so it's not clear cut. I totally agree with you.
Okay, so thank you very much.
Thank you. Thank you. Thank you.